This is all about the area of a triangle. This is in section 8.4 of the 8th edition of Pre-Calculus by Michael Sullivan. Anyway, we all know, hopefully by now, that the area of a triangle is given by, and to let you know that I'm using a different letter than the letter A, because I might need that for an angle, we're going to use A with a triangle in the subscript. But anyway, this is 1/2 base times height. So if I have some triangle, let's say something that looks like this. This segment right here would represent the height. If I let this bottom segment be B, I could let this be A. That's the area of a triangle. Now, if I happen to know this angle right here, angle theta, then it's not hard to show that the sine of theta is equal to h over a, because I'd be using this right triangle right here. H is the opposite, a is the hypotenuse. And so what I can do is I can solve for h, so h is equal to a sine theta. And then I can plug that in for h right here, and we get the following formula. The area of the triangle is 1/2 AB sine of theta, which means that you take two side lengths, multiply them together, and then take the sine of the angle between them and also multiply by 1/2, and that's a formula for the area of a triangle. So for example, if I had the following triangle, if I had little a equals 8, little b equals 6, and c equals 30 degrees, what I could do is I could say, okay, the area of this triangle, now notice when I draw this, and it doesn't have to be a super accurate picture, there's A, there's B, and there's C. So that would mean that this is 8, this is 6, and this is 30 degrees, which clearly isn't accurate in this picture, but that doesn't matter. So the thing to notice is that you have two sides and the angle that comes between them. You can use this formula right here to get it. So this would be 1/2 times 6 times 8 times the sine of 30 degrees. The sine of 30 degrees happens to be 1/2. And so my area of this triangle happens to be 24 times 1/2, which is 12. And that's basically how that's used. Now there's another area formula that has a proof that's far more complicated. If you're curious, it's on page 527 of the 8th edition of the Michael Sullivan book, you know, the gray one. But anyway, this is what's called Hero's formula, or Heron's formula. When I learned this in school, it was Hero without an N. But in most textbooks, they give an N here. And I'm really not sure where the discrepancy was, because it's not like this guy's name should have changed. But anyway, the area of a triangle is also given by the square root of s times s minus a times s minus b times s minus c, where s is equal to 1/2 of the perimeter of the triangle, so it's known as the semi-perimeter. So as you can see, this would be a useful formula to use if you have all the sides of a triangle, but you don't have any of the angles. So consider a triangle that has side lengths 4, 5, and 7. So all you would have to do to find the area of this triangle is compute the semi-perimeter. So S would be 1/2 4 plus 5 plus 7. And that would come out to be 8. So the area of this triangle using Hero's formula would be 8 times 8 minus 4 times 8 minus 5 times 8 minus 7 and the square root of that whole thing. Well, this would be 8 times 4 is 32, times 3 would be 96, times 1 would be the square root of 96. And of course, you could break that down. So you got 96, 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3, 4 square roots of 6. And that is how you find the area of a triangle, if you don't just use 1/2 base times height. See you guys later.